Hello everyone, and welcome back to the Fluctus Channel. The KC-135 Stratotanker has anchored American air power for decades, since the jet age. Derived from Boeing's Model 367-80, the design lineage behind the 707 airliner. The tanker was ordered in 1954, first flew in 1956, and entered service in 1957. A total of 732 were built, and the aircraft quickly became a crucial support platform in the U.S. arsenal. Its job was never glamorous, but it was decisive: carry fuel, meet combat aircraft in the sky, and extend missions far beyond what those aircraft could do alone. Over the decades, KC-135 has supported strategic bombers, fighters, reconnaissance aircraft, Navy and Marine Corps jets, and Allied air arms around the world. That long service life has only been possible because the aircraft kept evolving. Modern KC-135 R and T variants received more efficient CFM56 engines, giving them major improvements over the older KC-135A. According to the Air Force, the re-engined tanker can offload 50% more fuel, is 25% more fuel efficient, costs 25% less to operate, and is 96% quieter than the original model. Even now, the aircraft remains a serious machine. It can take off at gross weights up to 322,500 pounds. Cruise around 530 miles per hour, climb to 50,000 feet, and ferry itself more than 11,000 miles when configured for long-distance movement. In tanker configuration, nearly all of its internal fuel can be pushed through the flying boom, turning the jet into a force multiplier. That boom is what gives the KC-135 its signature role. A boom operator, working from the rear section of the aircraft, guides the telescoping refueling boom into a receiving aircraft while both aircraft fly at high speed and close spacing. In some configurations, the tanker can also use wing-mounted pods to refuel two probe-equipped aircraft at the same time. It is a technical mission that demands smooth flying, timing, and trust between crews. In combat aviation, range is power. KC-135 exists to manufacture more of it. That strategic value becomes especially clear during emergency launch procedures. In a crisis, tankers may be sent into a minimum interval takeoff, or MITO, launching one after another at dramatically reduced spacing. The sight is intimidating. Heavy four-engine aircraft thunder down the runway, only seconds apart, rotating into the turbulent air left behind by the jet ahead. The procedure grew out of Cold War logic, when crews understood that staying exposed on the ground during a surprise attack could be fatal. If the tanker force could get airborne fast enough, it could survive, regroup, and help launch the wider response. That is what makes a mass tanker departure feel so urgent. It is not simply about speed, it is about preserving the nation's ability to project air power after the opening shock of a crisis. Once those jets are airborne, their mission becomes practical. They build a fuel bridge, Fighters can now stay on patrol longer. Bombers can reach deeper into the map. Surveillance aircraft can remain on station. Rescue aircraft can push farther. When KC-135 refuels a B-2 Spirit, that importance becomes obvious. The stealth bomber approaches from behind, then settles carefully beneath the boom. For several seconds, the two aircraft hold this exact position as fuel begins to flow. No flashy maneuvering, only steady hands and disciplined formation flying. But that contact gives the B-2 the endurance to continue a strategic mission north of the Arctic Circle. The bomber carries the aura. The tanker delivers the reach. Tanker operations look smooth in the air because so much of the hard work happens on the ground. One major part of that preparation now takes place inside simulators. Boeing's KC-46 training systems show how the next generation of tanker operators works in a far more digital environment. Using large displays, camera views, and mission systems that turn refueling into a highly managed information task, as well as a flying task. Crews are not simply learning to hold altitude and pass fuel. They are learning how to process visual feeds, monitor systems, communicate clearly, and keep the refueling sequence stable while several moving parts come together at once. For operators, the simulator is where repetition builds calm. KC-135 simulator serves a different but equally valuable purpose. Because the aircraft has such a long service history, crews use simulation not only for procedural practice, but also to rehearse abnormal and dangerous events that cannot be safely replicated in a real jet. Engine problems, flight control issues, refueling malfunctions, runway emergencies, and weather complications can all be built into the scenario. That lets instructors push crews much harder than they could during a routine training sortie. It also explains why simulator training is sometimes linked to crash testing and mishap response. The point is to force pilots, maintainers, and emergency teams to think through the chain of events before the real thing ever happens. That realism carries over into live fire training built around a KC-135 airframe. In these drills, firefighters attack the kind of blaze that could break out around the fuselage, engine nacelles, landing gear, or fuel-heavy wing roots after an accident on the ground. The shape of the aircraft matters. The height of the fuselage, the access points, the fuel hazards, and the likely rescue routes all affect how a response team moves. For a tanker, the stakes are obvious. This is an aircraft built around fuel, and a fire involving a fuel-laden jet can escalate brutally fast. Crews train to cool the aircraft, control the flames, reach trapped personnel, and do it all under severe heat and smoke. Then, there is crash-damaged or disabled aircraft recovery, often shortened to CDDAR. This is the discipline that gets a wounded tanker off a runway or taxiway after a mishap. Recovery teams may stabilize the airframe, jack it up, replace or support collapsed landing gear, install dollies, rig tow equipment, and carefully move the aircraft without causing further damage. It is a heavy, methodical process, but it directly supports combat readiness. One disabled tanker can shut down a runway needed for the next launch wave. So while pilots practice getting airborne in a hurry, recovery teams practice clearing the damage in a hurry too. Put together, the simulator bay, the live fire trainer, and the recovery line reveal the hidden side of tanker power. They teach crews to stay organized under pressure and keep the mission moving even after something goes badly wrong there. If the KC-135 represents the tanker force that has carried U.S. air power, the Boeing MQ-25 Stingray shows where part of that mission is headed next. Built for the Navy, the MQ-25 is designed to refuel carrier aircraft without putting another pilot in the air. On a carrier, every deck spot and available fighter matters. For years, Navy strike fighters have often had to perform buddy tanking, passing fuel to other aircraft. The MQ-25 is meant to ease that burden and push more striking distance back into the carrier air wing. Its development has produced historic milestones. Boeing's T-1 test asset first flew in 2019, then in 2021 became the first unmanned aircraft ever to refuel another aircraft. It did not stop there. The same test asset later refueled an E-2D Hawkeye and an F-35C Lightning II, proving that the concept could work with multiple aircraft from the air wing. That progression matters because the MQ-25 is not just another drone. It is a dedicated aerial refueler designed to fit into the demanding rhythm of naval aviation, where aircraft must launch, recover, and operate in tight cycles over open ocean. The Navy lists it at roughly 51 feet long, with a 5-foot wingspan. The refueling itself looks different from Air Force boom operations. Instead of a rigid boom guided into the receiver, the MQ-25 uses the Navy's hose and drogue method. That means the tanker streams a hose behind it with a basket-like drogue at the end, and the receiving aircraft plugs into that moving target. It is a difficult procedure even between two crewed aircraft. Seeing an unmanned tanker perform it successfully is what makes the Stingray so important. It means the Navy is moving toward a future where autonomous systems can handle one of the most precise and sensitive jobs in military aviation. A major part of that capability sits in the pod mounted under the aircraft. Footage of pod installation reveals the equipment that turns the MQ-25 from a sleek test aircraft into a working tanker. This refueling store carries the hose and drogue system and becomes the center of the mission. Once it is attached, the aircraft has to be inspected carefully. Crews check mounting points, lines, surfaces, and fit because everything has to deploy cleanly and withstand the stresses of flight, extension, and fuel transfer. Even the pre-flight after-pod installation carries a different feeling. It is no longer just about preparing a drone to fly. It is about preparing a naval refueler to support manned aircraft from a carrier deck. That is what ties the MQ-25 back to the KC-135. The aircraft are different, but they answer the same strategic problem. Fast jets burn fuel quickly, and fuel is what determines how far power can reach. The KC-135 solves that problem with a large crewed aircraft operating from long runways across the globe. The MQ-25 solves part of it with an unmanned tanker built for the carrier air wing. One comes from the Cold War and still delivers global reach. The other points toward a future where unmanned systems help keep manned aircraft on mission longer. And that is why the image of tankers launching in a hurry matters so much. Whether it is a KC-135 lifting off in a minimum interval departure or an MQ-25 preparing for future deck operations, both aircraft exist to keep the rest of the force in the air at sea. That is the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.